So this is a lesson on solubility. Right, so fresh lemonade is a solution of water, lemon juice, and sugar. Right, now while you can dissolve a lot of sugar in water, there's actually a limit on how much sugar will be able to be dissolved in the water. And you probably have seen this when you've put too much sugar in hot tea or in hot coffee, and a lot of that sugar just sits at the bottom because it was unable to be dissolved. You went over the limit. All right, so the maximum amount of a solute that can be dissolved in a given amount of solvent at a constant temperature is called solubility. All right, so solubility is usually measured by how much solute can be dissolved in 100 grams of water at 20 degrees Celsius. All right, so the 20 degrees Celsius refers to room temperature, and 100 grams is just a standard that they use in science or to measure solubility. So we see a table here, and we have table salt, baking soda, and sugar. And then it lists the solubility in grams, right, of for each of those substances, right? And we see that table salt, the solubility is 36 grams. For baking soda, it's 9.6. And for sugar, it's 203.9 grams, right? So what this is telling us is that sugar is a lot more soluble. You can dissolve more sugar than you can baking soda and table salt, right? So only 36 grams of table salt can actually be dissolved in 100 grams of water, right? Whereas for sugar, 203.9 grams can be dissolved. And baking soda has the lowest solubility. You can only dissolve 9.6 grams. Right? So solubility, once again, solubility refers to the amount of solute that can be dissolved in a given amount of solvent at a constant temperature. Right? So temperature affects how much can be dissolved. If we look here, we have a list of several substances, solid substances: copper sulfate, potassium bromide, potassium chloride, potassium nitrate, sodium chlorate, and sodium chloride. Right? And we have three different lists of solubility for that according to temperature. So at 0 degrees Celsius, let's just choose one, say copper sulfate, the first one. So for copper sulfate, 23.1 grams can be dissolved at 100 degrees Celsius. Right? But if we go up, increase the temperature to 20 degrees Celsius, then 32 grams can be dissolved. And if we increase the temperature more to 100 degrees Celsius, then 114 grams can be dissolved. Right? So for solid solutes, when you increase temperature of the solvent, more of the solute can be dissolved. Okay. We often show solubility on solubility curves, and this is a graph where it's showing how much of a substance can be dissolved at a given temperature. So on our x-axis, we have temperature, and on our y-axis, we have the solubility in grams of the different substances. And if you notice that most of these curve, right, they grow, it increases exponentially for most of them as you increase temperature. Now, these are all solids, right? These were the ones listed in the table before, right? So as you increase temperature for a solid solute, more of that solute can be dissolved. Right, now, gases, actually, there's an opposite effect on gases. When gases dissolve in water, they actually behave in the opposite way. As temperature increases, less gas is able to be dissolved. Right, so on this table, we can see methane, CH4, oxygen gas, O2, carbon dioxide gas, CO, and helium gas, HE. And if you notice, they curve downwards. So as you increase temperature, less is being able to be dissolved. Right, and if you can remember back to the Diet Coke and Mentos experiment, as we heated the Diet Coke, the explosion got larger. So why did it get larger? Well, as we increased the temperature, it caused the molecules to move faster and less carbon dioxide gas was able to be dissolved in that in the Diet Coke, right? Because remember, as you increase temperature, it's going to expand. The liquids are going to expand. The gases are going to expand. They're going to move faster. They just dissolve less. And so we had a lot larger explosion in the hot Diet Coke. All right, so as we increase temperature for a gas, solubility decreases. Now, there are three types of solutions according to solubility. Right? So we have unsaturated solution, a saturated solution, and a supersaturated solution. Yeah. For an unsaturated solution, solutions that have less solutes than can possibly be dissolved at a given temperature is called an unsaturated solution. Right? So I like to think of an analogy of trains or to explain how this works. And I think that makes it very easy to understand. So if you have a train and you only have a few passengers on the train, so that there's a lot more available seats, a lot more people could fit on that train, that would be an unsaturated train, or in our case, an unsaturated solution. You could dissolve a whole lot more solutes in that solution when it's unsaturated. A saturated solution is a solution that contains as much solute as the solvent can hold at a given temperature. Right? So in this case, the train would be completely full. There's no more room for anybody else to fit on. It's at full capacity. Right? So a saturated solution, it is holding as much as it can possibly hold at that given temperature. Right? So the last case is a supersaturated solution. Right? If a solution holds more solute than it can normally hold at a given temperature, then it's called a supersaturated solution. Right? So if we think of a train, the train would be overflowing its capacity. Right? That would be supersaturated. Right? So supersaturated solutions are very unstable. That train comes to a quick stop. A lot of those people are falling off the train. Same thing with supersaturated solutions. They make these under special conditions. They heat it up very carefully, add the solutes, add the extra solute so that it goes more and it stays dissolved, but it's very fragile. If anything knocks it or jars it, the solute will crystallize out, is what you see in the picture to the left. And you can see the solute crystallizing out. Now, we use this to make rock candy. We heat up water, add a lot more sugar than what the water would normally hold, and then we allow it to cool, and that sugar crystallizes out, and we make rock candy. Crystals in nature are also made the same way. All right. When we're in science, they often show solubility on graphs called solubility curves. Right? The point along the line, any point along that line is a saturated amount. So it's giving you, it lists a saturated amount, but you can also tell unsaturated and supersaturated solutions using these graphs. Okay, so once again, any point along the line shows the amount of solute that can be dissolved at a given temperature. So a way that you might be asked questions can be seen in this example. Right, so at 40 degrees Celsius, 130 grams of sodium chlorate, NaClO3, can be dissolved in 100 grams of water. Right, so if we look at the x-axis, we find the 40 grams, carry it up to where you see the line for the substance you're looking for. So in this case, it's NaClO3. Right, so the red line is carried up to the line. Okay, and then we're looking for 130 grams. Right, so 40 degrees Celsius and 130 grams meets right along that line. So sometimes you might be asked how much can be dissolved at a certain temperature, or at what temperature can a certain amount be dissolved. And you would just find that point along the line. Okay, so another way you'll be asked questions is whether a solution is saturated, supersaturated, or unsaturated. And in that case, you'll be given the temperature and the amount given. Okay, so any point below the line would be an unsaturated solution. So let's say we're doing KBr, potassium bromide. All right, so any point down here, if the points reach down here, would be unsaturated, right? Any point along the line is saturated. Any point above the line, so anything up here, would be a supersaturated solution, right? That's how you read the graph. How you can tell what type of solution is by reading a graph. Right now, we also often list solubilities in tables, and you can also determine the types of solutions by reading a table that shows the solubility of various compounds at a given temperature. Right. So when the amount listed in the table is a saturated amount. And so if you're asked how much can be dissolved of any given substance here, say baking soda, at this temperature at 20 degrees Celsius, you would know it's 9.6, and that would produce a saturated solution. Okay, if you wanted to know unsaturated or supersaturated, if you were given an amount less than what's listed on the table, it would be unsaturated. So let's say you were given an amount of 32 grams. What type of solution would be formed if 32 grams of salt was dissolved in 100 grams of water at 20 degrees Celsius? It would be unsaturated, right? If you were given if you were asked what type of solution would be formed if 40 grams of salt was dissolved in 100 grams of water at 20 degrees Celsius, it'd be supersaturated. Okay, so that's how we read a table, right? If the amount's less than the amount, if the amount given is less than the amount listed in the table, it's unsaturated. If the amount given is more than the amount in the table, it's supersaturated. If the amount is equal to the amount given in the table, then it's saturated. Okay, so here's the I can statements. I can define solubility. Solubility was the amount of a solute that was able to be dissolved in a solvent at a given temperature, right? Describe the effects temperature has on solid solutes and gas solutes, right? So if you remember, for a solid solute, as we increase temperature, more solid solutes could be dissolved. For gas solutes, it was the opposite. As you increase temperature, less gas solutes can be dissolved. Distinguish between a saturated, unsaturated, and supersaturated solution. So a saturated solution holds as much solutes as that solvent can hold at a given temperature. An unsaturated solution holds less than what could normally be held in a solvent at that given temperature. And a supersaturated solution holds more than what could normally be held in that solvent at a given temperature. I can read a solubility graph and a solubility table to determine how much of a given solute can be dissolved at a given temperature and determine the type of solution formed. Okay, so on a solubility graph, the amount given is the saturated amount, how much can be dissolved. Same thing as a solubility table. The amount in the table, stated in the table, is the saturated amount, how much can be dissolved at that given temperature. If the amount is under the line on a graph, it's unsaturated. If the amount is greater than the line on the graph, then it's supersaturated. If the amount is less than stated in the table, it's unsaturated solution. If the amount is more than what's stated in the table, it's a supersaturated solution. Right, so that's how you read solubility graphs and tables. Right, that's the end.